All right, let's dive into one of the most important, fundamental building blocks in all of Python, the for loop. Seriously, once you get the hang of this, your code is going to be so much cleaner, shorter, and way more powerful. We're going to break it all down.
So think about this for a second. It's a problem we all run into when we're coding. How do you handle doing the same thing over and over? I mean, what's the best way to, say, print 10 different names without just copying and pasting the same line of code 10 times?
Well, Python has this really elegant answer, and it's called the for loop. It's built for something called iteration, which is just a fancy word for a super simple idea, going through items in a collection one by one.
Okay, so here's our game plan. We'll kick things off with the absolute basics. Then we'll check out the incredibly useful range function and see how to loop over lists. From there, we'll get into some finer control statements, and finally, we'll see how it all comes together with nested loops and a real-world example. First things first. Let's break down the essential DNA of every single for loop. You know, the core structure it's built on. Once you get this part, I promise, you're well on your way.
So the syntax is actually really simple and almost reads like plain English. It's got three key parts. You have your variable, which is like a temporary nickname for each item as you go through. Then there's the sequence. That's the list or collection you're looking through. And finally, the indented code block, which is just the action you want to do over and over.
Now, let's give our loop a little superpower. Let's talk about the range function. This is going to be your new best friend anytime you need to run some code a very specific number of times. And what's cool is that you can use range in 3 different ways, depending on just how much control you need. You can give it 1, 2, or even 3 arguments. Let's start with just one argument. If you tell range a single number, like 5, it creates a sequence for you that starts at 0, and here's the key part. It stops just before it gets to that number. So range 5 gives you the numbers 0, 1, 2, 3, and 4. Okay, next up, 2 arguments. This is where you get to set your own start and end points. So if we say range 2, 6, our loop is going to start counting at 2, and again, it stops right before it hits 6. So you get 2, 3, 4, and 5. But what if you want even more control? Well, the third argument is the step. With range 0, 10, 2, we're saying start at 0, stop before 10, but only count up in steps of 2. This is awesome for when you only want to grab, say, every other number.
And get this, you can even count backwards. All you have to do is make the step a negative number. So here, we're starting at 5 and counting down by 1. How cool is that?
So for loops are great for numbers with range, but that's not all they do. They work beautifully with all kinds of sequences, and probably the most common one you're going to use is a list.
Just look at how clean and readable this is. The loop just grabs each item from our fruits_list one by one and temporarily calls it fruit. And then for each one, it runs our print command. So it prints apple, then banana, then cherry. It's so simple, but so powerful. Okay, so your loop is up and running, but what if you need to change its behavior while it's in the middle of its job? Like, what if you need to stop early, or maybe just skip over a specific item? That's exactly where loop control statements come into play.
We've got 3 main tools in our toolbox for this. Break is for when you need to exit the loop right away. Continue is for when you want to skip the current item and just move on to the next. And pass, well, pass literally does nothing, which, believe it or not, is actually really useful.
Think of break as your emergency exit. In this code, the loop is supposed to count all the way up to 9, but we've got a little tripwire in there. If the number ever equals 5, we hit the break statement. The loop just stops dead in its tracks. That's why the output only goes up to 4.
Now, continue is a lot less dramatic. It doesn't kill the whole loop. Here, our condition is checking if the number is even. When it is even, continue just says, hey, skip the rest of the code for this round and jump straight to the next number. And that's exactly why only the odd numbers end up getting printed.
And then we have pass. It's a bit strange because it's a placeholder that does absolutely nothing. But imagine you're sketching out your code. You know you're going to need a loop here or an if statement there, but you haven't written the logic yet. You can just pop in pass so Python doesn't give you an error. It's super handy.
All right, time to put all the pieces together. This is where the magic really happens, when we combine loops and control statements to start solving more interesting and complex problems.
You can actually put a loop inside of another loop. We call these nested loops. And the way they work is for every single time the outer loop runs, that's our I loop, the entire inner loop, our J loop, will run from start to finish. This is an absolute must-know for working with things like grids or combinations.
Okay, let's look at a practical example. We're searching for CS in a list of subjects. Our loop starts checking each one. When it gets to CS, our if statement sees a match. It prints CS found, and then break immediately stops the loop. Why? Well, why would we waste time checking physics and biology if we've already found what we were looking for? It's just a really smart and efficient way to code.
And that's really the foundation of it all. From the basic syntax to controlling the flow and even nesting them, for loops are a core concept you will use every single day as a Python programmer. So keep playing with them. Happy coding!